Okay, algebra students, today we are going to take a polynomial and we're going to be given either one of the factors or one of the roots, and we're going to find the other roots or the other factors depending on what the question is asking us. So if we go back and we remember the fundamental theorem of algebra, part of that states that whatever the degree of the polynomial is, and remember the degree of a polynomial is the largest exponent value of the polynomial. So whatever the degree of the polynomial is, that's equal to the number of solutions that the polynomial has. And we've talked about solutions. There's other words that mean solutions as well. So we could say solutions, we could say roots, we could say zeros, we could even say x-intercepts. Now, solutions, roots, zeros, x-intercepts, they don't always have to be real numbers. If all the solutions were real, whatever that polynomial graph looks like, however many turns it has in the end behavior, all those kinds of things that we already talked about, it could cross the x-axis if it's a degree of 5. It could cross the x-axis 5 times. That means it has 5 real solutions. However, it could only cross the x-axis maybe once, which means it really only has one real zero, one real solution, one real x-intercept, one real root, which means all the rest would be complex, which has an imaginary unit inside of it, which makes it complex. Okay, so what we're going to do for our purposes is we're going to take this polynomial and we're given a factor of x minus 1. And what we want to do is we want to use that factor. We want to find the other remaining factors and find the other zeros as well. Once we have the factors, the zeros are very easy. So we're going to use synthetic division to do that. So if we start with this polynomial here, and we know that one of the factors is x minus 1, we can synthetic divide. So let's do that. So if you notice, I'm not missing any terms here. So I have 1, negative 17, and positive 15. And since my factor is x minus 1, set that equal to 0, I'm really synthetic dividing by 1. Okay, so if we remember what we do when we're synthetic dividing, we add inside the house, so we add going down, and we multiply outside the house. So since there's nothing to add going down here, 1 plus 0 is just 1. Now we're on the outside and we multiply those. So 1 times 1 is 1. Add going down, 1 plus 1 is 2. Multiply, 1 times 2 is 2. Add going down, which would be negative 15. Multiply again, which is negative 15. And add going down, which is 0. Now my remainder is 0. And remember, we used to say that if we are synthetic dividing by one of the roots, which in this case would be 1, we should get a remainder of 0, otherwise we did something incorrectly. So if you think about it, synthetic dividing by 0, because again, solutions, roots, zeros, they all really mean the same thing. Synthetic dividing by 0 should give us a remainder of 0. Now we write the depressed polynomial. We have x squared plus 2x minus 15. And again, how do I know that this happens? Well, we start with x to the third. When we synthetic divide, we always decrease by 1 exponent. So the new degree, which was a degree of 3, now becomes a degree of 2, and it's a quadratic. So we could factor it, we could use quadratic formula, all those kinds of things. If you want, you can use the quadratic formula on your calculator. What I'm going to do for this one, I know this one is factorable. I'm going to factor like we have just done with our guess and check method. So let's see, I know that x times x is x squared. So negative 15, my choices are negative 5 and 3, maybe 5 and negative 3, start with those. So let's see here. I'm going to go with 5 and 3, and I want it to be positive 2. So I probably want the 5 to be positive and the 3 to be negative. Let's double check before I go on to see I'm doing it correctly. 5 times x is 5x. X times negative 3 is negative 3x. So 5 plus negative 3 is 2. So that's okay. Then we can set each factor equal to 0. Now, I could stop right here if it said find the remaining factors. So when I write my answer, I'll write the remaining factors, but then I'll also write them as zeros. So I already have the remaining factors, x plus 5 and x minus 3. But I'm going to keep going because I want to solve this. So x equals negative 5 and plus 3, x equals 3. So my factors, there's 3 factors because it's a degree of 3. The one I was given, x minus 1, and then the 2 that I found, x plus 5 and x minus 3. Okay, my zeros, or my solutions, my roots, all of the above, we'll call them roots, are just the answers, just the numbers. So positive 1, negative 5, and positive 3. Positive 1, negative 5, and positive 3. That's what x equals. Those are all real numbers. So this graph, if you were to check it on your calculator, it would be a degree of 3. It would cross, it would look something like this. We have 1, we have negative 5, and we have 3. It's positive, so it would be something like this if you were to graph it. That's what the graph would look like. Go ahead and check it if you want. Okay, problem 2. So problem 2, hold that thought. This one has a degree of 4, all right, and it gives us 2 solutions. Now, this time it gives us the solutions. So if the solutions are given to us, that's what we synthetic divide by. The solutions are the zeros or the roots, don't forget. So here it gave us the factor, so we had to find the 0 or the root to synthetic divide by that. But here it tells us what to synthetic divide by. We have a choice of which one we want to do first. It doesn't really matter. I'm going to start with positive 1. So I am going to put the 1 there, and then we have 1x to the 4th minus 2x to the 3rd minus 8x squared plus 18x minus 9. Okay, let's synthetic divide. Add inside the house, 1 plus 0 is 1. Multiply outside the house, 1 times 1 is 1. Add inside, multiply outside, add inside, multiply outside, add inside, multiply outside. And what should my remainder be again? 0. Good. Okay, now, instead of writing this out like I did here, since I have another solution or another 0 to synthetic divide by, I'm going to keep synthetic dividing. Watch what I'm going to do now. I'm going to change colors. These next 4 numbers, I'm going to synthetic divide by my other solution, which in this case I think is 3. Okay. Nothing to add. 1 plus 0 is 1. Multiply on the outside. Add going down. Multiply on the outside. Add going down. Multiply on the outside. And what should my remainder be again if I'm synthetic dividing by a root? That's correct. It should be 0. 3 times negative 3 is negative 9. Oh man, life is good when we get zeros for remainders. Okay, now I'm going to write this out. Now, pay very close attention here. I've never done this before. We synthetic divided twice. We started with x to the 4th, so this would become x to the 3rd. Synthetic divide again. This becomes x to the 2nd. Or you can think about it, we always want to end with a quadratic because we know how to solve quadratics. We can factor, complete the square, quadratic formula, all those good things. I'm going to factor this one again, guessing and checking. X times x is x squared. Negative 3, perfect number, only two choices. Negative 3 and 1 or 3 and negative 1. So let's see, I'm going to go, since we want positive 2, I'm guessing it's going to be 3 and negative 1. 3x minus 1x is positive 2x. That's good. That's really good. Okay, let's solve it. So x plus 3 equals 0, and x minus 1 equals 0. X equals 3, but it's negative because we subtracted it. And x equals 1. Now, how do I write my answers again? If I want factors, I have, first of all, I have the 2 that are up here, which if it's x equals 3, it's x minus 3. If it's x equals 1, it's x minus 1. And then the 2 that I found down here, x plus 3, x minus 1. There's all my factors. If I want roots, okay, 3 and 1 were already given to me. And then negative 3 and another positive 1. All right, so this one is interesting. This is a degree of 4. It has 4 real solutions, but one of them is repeated. So if I go to negative 3, doesn't look like a negative 3, there we go. We can go to 1, and we can go to 3. It's positive, so it's going to start by opening upward. Now I have to think about this one here for a second, how this is going to look. It should look something like that. So it doesn't cross the x-axis here, it just touches it because that is repeated, and then it goes back down and crosses at 3. That is solving a polynomial given a root or a 0 and finding the other roots or zeros or factors in this case too. If you have any questions, please ask them in class tomorrow. Thank you for watching the video, and have a good day, guys.